Good afternoon, everyone, and welcome to the last session in the payments track. The last one between you and lunch, but I'm being told it's going to be worth it. Seamless and secure, the rise of payment passkeys. Going to hand over to Kevin Crockett from Visa. Thank you, Kevin.
Okay, perfect. Thank you very much. Hey, everyone. I'm Kevin Crockett from the Visa Risk and Identity Solutions team. I head up our product platform that focuses on consumer authentication, which is our merchant acquiring facing authentication solution. So today we're going to talk about, shocker, passkeys, but passkeys in the context of payment authentication. And if you look at the agenda, I think the original title of this was something about AI-driven passkeys. I think our marketing team just got a little overzealous in the submission that they input as far as the title. These aren't Skynet-driven passkeys or anything like that. So I just wanted to make everyone aware of that. So first and foremost, just kind of setting the stage, very similar context you heard in the prior session is that C&P digital commerce continues to rise year over year. And as e-commerce continues to rise, there are continued challenges that we're facing. So one being the rise of fraud. And then honestly, probably the bigger issue is what we call the acceptance gap. So card not present approval rates are nowhere near card present approval rates. And a lot of times what we see is that the fear of fraud is often a bigger problem than fraud itself when you look at it from a dollar standpoint, sometimes 7 to 10x higher depending on the market. So what we're looking to do is create solutions that allow everyone to seamlessly and securely accept transactions and then reduce that fear of fraud and, of course, eliminate as much of the fraud itself as possible. So I think everyone here knows what biometric authentication is by now, hopefully, but essentially what we're looking at here is that when biometric authentication is applied to a transaction, there is a very drastic reduction in the actual fraud that we see. So we see around a 55% reduction in fraud when the customer is authenticated using biometrics compared to other methods that are available, things like static passwords, knowledge-based questions, OTPs, things of that nature. So again, very similar context to what you've been hearing. So here is how Visa is looking to solve for it. So Visa Payment Passkey is a new digital identity solution that allows a consumer to authenticate to themselves real time during a payments transaction, leveraging the inherent biometric capabilities that are available on their device. So in this particular scenario, Visa has created its own FIDO2 server where we are acting as the relying party. So what that means is we are facilitating the device recognition. We are facilitating and managing the cardholder and consumer experience, and also managing the privacy-preserving authentication that's taking place and sharing that FIDO proof data with the issuers. And we'll go into more detail on what this looks like, and you'll see some different flows and screenshots. But we're working to support this across multiple channels. So supporting card-on-file tokens, supporting PAN entry, supporting EMV3DS flows, and of course, supporting future state digital wallets, things like click to pay, further integration with SBC, kind of interjecting all of the things that you've heard in the prior few sessions. So why are passkeys valuable? And they're really valuable in each part of the payment processing domain. So looking at it from the merchant standpoint, so passkeys qualify for liability protection as a fully verified and fully authenticated transaction. So when we look at the differences and why passkeys are beneficial, not just from the actual fraud reduction, but it's also the commercial treatment that's ultimately applied to a transaction. So things like fraud liability shift if you're a merchant, things like interchange reduction in certain markets where that may apply. As a merchant, you would benefit from all of those things by running passkey authentication. So it supports PSD2 and supports two-factor authentication requirements across different regulated markets across the globe. And really, it helps increase purchase conversion by reducing cart abandonment. I know that we've seen a couple of variations of different challenge flows and methodologies that exist today in the 3D Secure context that are reliant on a consumer successfully getting an OTP, entering that credential on the merchant checkout page, completing authentication that way. A lot of that can be clunky. OTPs can be susceptible to man-in-the-middle style of attacks. OTP delivery rates in certain markets across the globe aren't always great. So the biometric FIDO authentication is a much cleaner and streamlined user experience that in turn helps increase authentication success rates, which has a direct correlation to the ability to securely accept payments. So from a cardholder standpoint, or a consumer standpoint, there is a one-time enrollment that is required to actually register the passkey, which is binding your payment credential to that particular device. And then you can easily use that passkey experience on any merchant globally that participates. So that means you're breaking the reliance on SMS OTPs or needing to remember passcodes. And again, it's a very consistent and familiar user experience. So it's the same type of authentication you're using to unlock your device anywhere between 20 to 50 times a given day. So when we look at the flip side then, look at it from the issuing side, so very, very similar benefits, obviously. Everyone wants to reduce fraud. Everyone wants to increase payment acceptance rates, right? So from the issuing side, fraud reduction helps reduce false declines and increase customer satisfaction so that you're not potentially rejecting legitimate customers that are trying to transact online. It can help reduce the cost of verification solution maintenance. So we talked a bit about OTPs and some of the challenges globally that we've seen there, but also OTPs can get expensive. So passkeys are a great way to reduce some of that operational cost and overhead. And probably one of the key KPIs that, as we're working with our issuing clients, is continuing to help drive top-of-wallet usage. Okay, so what does this look like in practice? So we have a pretty simple decision tree here, and really the way that we're positioning this is an extension of existing 3DS capabilities that a lot of our clients already have in place today. So by the implementation of a few net new calls into us, you can facilitate a full end-to-end passkey and/or 3DS experience. So when we look at what this looks like here, the first thing we're doing is, of course, a device compatibility check. So is the device itself compatible with FIDO biometric authentication? If it is, great, we can move on to the next step. If not, you can fall back to legacy authentication methods that are available. So the next thing we're doing is okay, we have a FIDO-capable device. We are now going to check and see if there's an existing passkey registered to that device/payment credential combination. So if it comes back from the core service that no, there is not in fact an existing passkey credential for that device and credential combination, we can then take the user through an enrollment process. And I'll show you what that looks like in a few screenshots and how we're handling the enrollment. There's a couple of different flavors on how we're processing consumer and cardholder enrollment. But as was mentioned in previous sessions, there needs to be an initial two-factor authentication that is run. So that can be done via any issuer ID and V that's available. It can be done via EMV 3DS. But once that two-factor authentication is done and complete, the consumer can then be put through the FIDO enrollment process, where they're opting into terms and conditions and understanding that they're creating a passkey. And then from there, that FIDO proof data can be shared with the issuers, and now we have a fully registered passkey that can be used on any participating merchant. So then the ideal happy state then is next time I come, I'm using a FIDO-capable device that already has a passkey linked to it. We do the passkey enrollment check, surfaces up, yes, we already have a credential for this combination of device and PAN, and we can go right to the FIDO authentication. And then from there, the FIDO assertion data can then be shared with the issuer either via existing EMV 3DS rails, which is what Henna touched on earlier, or via existing token rails that are there today. So I think the key thing here to call out is that the result of sharing that proof data with the issuer via either of these channels results in an electronic commerce indicator and some sort of cryptogram. So in the EMV 3DS protocol, you would get back a CAVV, From our token flows, you would get back a TAVV, but in any event, you would have an ECI 5 and a CAVV or TAVV that is then sent in authorization, which qualifies that transaction for the commercial treatment applied to passkeys, liability protection, all of those good things. And this is important because there's upfront changes that like a merchant would need to do to support facilitation of the passkey experience. But when it comes to processing the corresponding authorization message, there's no additional data points that need to be sent in there. So there's no additional technical lift or any sort of kind of ecosystem compatibility concerns that would be a part of that. So enrollment. So we talked about enrollment, which is really one of the most critical aspects of this whole process is we need cardholders and consumers to enroll. We need them to opt in. We need them to want to be a part of this experience. So what I'm going to show you in some of the screenshots here is kind of what we call an enrollment during or really post-purchase. And that's one flavor of enrollment that we talk about with our prospective clients is that once a purchase is complete and confirmed, you can then present the, hey, do you want to make this a better, more seamless experience moving forward? Go through the passkey enrollment process then. One other common area that we would like to see applied is during an initial creation of a payment profile or during any sort of instrument management in an existing wallet. If I'm going in and introducing a new card or creating a profile on a merchant for the first time, run through the two-factor authentication, prompt for the passkey enrollment so that it can then be used for future use. But really, ideally, where we're going to see probably the best adoption and the best scale of this is by working with our issuing partners to mass educate and mass enroll their cardholders. So if I'm logging into my mobile banking application or bank website, I'm prompted to say, hey, we have passkeys, here's what they are, here's what they do, and be able to basically register and enroll all of your passkeys in one foul swoop so that we're not reliant on that needing to be done on an individual kind of transaction basis. So with Visa sitting in the middle as the reliant party and kind of owning the federation here, is that once that passkey is enrolled one time, and again, a passkey is a particular payment credential bound to a specific device, that passkey can then be used at any participating merchant. So again, it is just a one-time enrollment. Okay, so then what does this ultimately look like here? So starting on the left-hand side here, just kind of going through the user experience. And I have screenshots in this demonstration. The live videos did not make it into this. We do have those available at our booth, or you can just come meet any one of us separately, and we're happy to walk you through it. But you can see here we're on bicycleshop.com. We're already on the purchase confirmation screen here. So the assumption here is that we've gone through SCA on this transaction, so we have a fully authenticated transaction. It has been approved, and then you can see as a merchant, I'm rendering this frame that says, hey, do you want to make this a better experience moving forward? Do you want this to be quicker, more streamlined? Do you want this to be more secure? Let's go ahead and create a passkey. So the customer prompt is then displayed on the actual order confirmation page. And this is a critical call out here because this is done after the order is confirmed because we don't want to introduce any additional friction to the actual point of checkout that may lead to further cart abandonment. That's been one of the historical major concerns with things like EMB 3DS is that it causes abandonment and purchase conversion issues. So we want to make sure we have a confirmed authenticated order, and then we're presenting the passkey enrollment option. So customer hits create passkey now. They're then redirected over to the Visa binding service, which again shows you some basic information, what passkeys are, there's terms and conditions. If you scroll down here, there's different links that give more information about passkeys and why they're beneficial. But the consumer sees kind of the physical representation of their card art, last 4 digits, device information, and then they can opt in and say, yes, I want to create a passkey. So from there, whatever biometric authentication is available on the device kicks in, it completes, it's successful, and then ultimately a passkey confirmation screen is then displayed to the consumer where they can update the email address that they would want a confirmation sent to. And within this confirmation email, the consumer is going to get information, again, just confirming that they have successfully registered their passkey. there'll be a link to a Visa-hosted page where a consumer will have the ability to go in and see all of the passkeys that they've registered across different issuers, across different devices, and be able to manage them from one single location. So I, as a consumer, will have the ability to go in and expire or delete passkeys. Let's say I lose one of my devices. I want to log into the centralized service. I can manage my passkeys there, on top of course, being able to manage that within your mobile banking application as well. So that's the enrollment flow. That's the enrollment post-purchase, if you will. So ideally, the future state here, 99% of the time, once that enrollment happens, is this experience. So similar to what you've seen in other presentations so far today, I'm now on kitchen.com, so a completely different merchant. Although I'm using the same payment credential, I'm on the same device, using the same browser. So if we go back to that decision tree here, as the payment details are entered, we're doing that passkey lookup. It surfaces up, yes, we do have an existing credential that is linked to this device in PAN. So we can go right to the passkey, the FIDO authentication experience, biometric kicks in, and then you're right to order confirmation. So at this point, you have a fully authenticated, fully secured transaction that applies for all of those program benefits based on where the transaction is being processed. So again, that's passkey enrollment here. That's a one-time thing. We have passkey authentication. And then, yeah, that was actually all of the slides I had. I do want to open it up and see if there's any additional questions, comments. There's a few here.
All right.
You in the room here?
Yeah, get a mic over. I don't know, is June around? Otherwise, I'll hand this one off. Mike, you're first.
A couple questions. Does this need any WebAuthn extensions, or is this generic passkeys?
This is the standard WebAuthn. Yeah.
Okay, so this, for instance, doesn't need secure payment confirmation that Doug talked about.
Yep.
Okay, that's what I thought. The other question is, on what platforms will this work today? I guess, actually, my first question answers that one, doesn't it? Because if you just need standard FIDO, you're good.
Yep.
Thank you.
Sure.
Okay, before we go there, I have two questions in the app, but they are both related, so I'll just ask this one. Basically, it says, what do merchants need to do to enable VPP for their customers? And then the second one is, what sort of code integration is needed on the merchant side? So maybe you can answer those two together.
Sure, yeah, so there's an additional new calls that a merchant, an integrator, an ISV would need to make to facilitate this. So there's the device compatibility check call, the enrollment, the authenticate calls, and again, if they are already an existing 3DS user, so they already have the connectivity built out through a 3DS server to send data through the directory server into the issuing bank ACS platforms, they can leverage that existing connectivity and that existing infrastructure to pass through the FIDO proof data, receive back the ECI and CEVV and all of those things. So I guess it really depends. There's definitely a few net new integration points for just managing the FIDO experience. If you're not already leveraging EMV3DS in some capacity today there would be additional work to connect into a 3DS server.
Okay, any questions from the room?
Yes, actually, two very quick ones. The first one is here, at this point, you were saying, so in this example, we have already registered, we are using the same device, the same card, the same browser, I think that you mentioned.
Correct.
Is it important to use the same browser, or I could be using another browser?
It is. This binding is specific to the device, browser, and PAN combination.
Okay. And the second one related to PSD2, so is there any concern? So the passkeys are sync passkeys here. Are they going to be roaming? Is this going to be compliant with PSD2? Is there any limitation, or how do you solve it, the device binding part?
Yeah, so again, similar answer to I think what Doug gave during the first discussion is that we'll want kind of more of like a legal response to that, but the idea is that yes, this is a form of stronger two-factor authentication that not even just in PSD2, but any market where there's regulation on strong authentication of digital commerce, that this would be a mechanism that could apply in lieu of existing, EMV3DS SCA capabilities. But yes, that is the idea, is that is a fully PSD2 compliant solution that satisfies those requirements for authentication.
Okay, one more question in the app. If the bank is also using passkeys, is that a challenge to help users understand what this new passkey enables and why they now have more than one?
I'm sorry, can you repeat the question?
Yeah, if the bank already, let's say this card is issued by Digital Bank, right? Let's say I already have a passkey for Digital Bank. Do I now have two passkeys, one for this service and one for Digital Bank? Or is the idea that I can use the passkey that I have at my bank for this service as well?
So this service is built on Visa acting as a reliant party as opposed to the issuer in that scenario. So they would be separate in that use case. One of the things that we're also exploring is within our own issuing partners, within their existing EMV3DS capabilities, leveraging passkeys as a separate challenge method as a replacement for OTP. So that's kind of where there is some intersection there. But in this scenario, for this particular solution, Visa is the reliant party. So I think that's the key difference there.
Got it. Any questions from the room? Okay. Go.
So would it be correct to assume that this is sort of what in the technical world is called a polyfill for a secure payment confirmation? So the day we have actual secure payment confirmation, this would go away?
I wouldn't say necessarily that it would go away, but we need to ensure that the products and features are working together and providing a consistent and good experience to the end consumer. So I don't think by any means that developing this passkey service becomes throwaway work when SBC comes to full scale. It's more about how do we make sure that these things are truly interoperable and can work together.
Yeah, I had a user friendliness question. For the checkout screen that you have, you're still requiring the user to type in the 16-digit credit card number and everything else, right? Is there any way to just pull up the available passkeys, I guess, on that device since they were already registered?
Yeah, so this is just an example that just shows one use case where, yeah, this is kind of a full kind of pan entry, but card on file, token on file, we can still render this experience with those situations as well. It's just what the demonstration was built off of, but those are supported.
And I know that maybe that's not my job as program chair here, but I will mention that is exactly one of the conversations we're having right now, is how the intersection with things like MDocs and other types of, I guess, credentials might help even make that initial step simpler. So definitely a conversation that we are interested in following, and I think it's tied into the trust signal and all these other discussions as well. So certainly something we should chat about more offline. Yeah, for sure. Okay, any more questions from folks in the room here? If not, there's one more on the app. I think you answered this already, but I'll pose it anyway. Is Visa using device-specific passkeys? If the passkey is synced, is there an additional device allowed or additional authentication needed?
Yeah, so I think, again, these are passkeys that are linked to the specific device and browser combination, so we do need to verify the identity of the consumer on each device. So I think that's a similar question from the prior session, but yeah, same concept there.
Okay. If we have no more questions, then let's thank our speaker again. Thank you.
Okay, thank you.